Alright class, welcome to section 5.3, the other trigonometric functions. So sine and cosine definitely are the main trig functions, the ones that we'll be using mostly. But there's more. In fact, there's 6 trigonometric functions. So I have learned of them, but we're going to go over them nonetheless. Tan theta, which by the way, tan stands for tangent, okay, is simply the ratio between the sine and the cosine function values. Now, sure enough, you've learned that sine x is the sine theta, sine of an angle theta is the y-coordinate, right, of a point you're landing on, and cosine is the x-coordinate. So sure enough, tangent's basically going to be y over x. Okay. Now, cotangent is the reciprocal of that. So it's simply cosine theta over sine theta. So in other words, if you think about the x and y coordinates of the points on the unit circle we've been talking so much about, is simply the x coordinate divided by the y coordinate. Okay. Secant theta is simply the reciprocal of cosine. I know you'd be very much tempted to say sine, but no, secant is the reciprocal of cosine. So in other words, let me write this. And by the way, so I won't have to switch pens, see it. That's the cosecant. So secant's the reciprocal of cosine. And cosecant is the reciprocal of sine. So it's 1 over y. Right. So you have them all in terms of the x and y coordinates, those points on the unit circle, or if you have the sine value, cosine value, you can just take the ratios of that, which basically, exactly as I said, in fact, we have names for these. These we call the ratio identities. So in other words, the fact that tangent's the ratio between sine and cosine, cotangent's the ratio between cosine and sine. So these formulas are also called the ratio identities. These are reciprocal, but before we even finish that, there's one more reciprocal identity. So as you see from here, tangent sine over cosine, but cotangent's cosine over sine. So clearly that cotangent is the reciprocal of tangent. Okay, so these 3 formulas here form what we call the reciprocal identities. And they're going to be coming in handy very much. So we're going to be using these formulas in this section quite a bit and moving on quite a bit more. So again, secant's the reciprocal of cosine, cosecant's the reciprocal of sine, cotangent's the reciprocal of tangent. Good. Before we're going to play with these formulas, the first application I'd like to go through, the one most importantly, is finding the exact values of certain angles. So in other words, I might be asking you to find secant of 45 degrees, right? Exact value of, in other words, don't touch your calculators, okay? So for this, of course, we want to think about the exact values of sine, cosine, and I'm now extending this table or this chart to tangent as well. And I'm going to put this in parentheses, the radian degrees of this. So 0 degrees is 0 radians. 30 degrees is a pi over 6. Again, once you get to calculus, you will only be using radians. But as we saw in the last section as well, so this is the radian value, this is the degree value. So I'm just saying that even though you're going to only have to be using radians in calculus, many times it's just so much easier to think back of degrees and then put it back in radians. Okay, it's for me at least. Okay, so do you remember what these numbers were? Sine of 0, 0, right? Remember how we filled 0, 1, 2, 3, right? 1, 2, 3, and then 4, but I'm not going to write that. Then divide them all by 2. Take the square roots of these numbers, divide them by 2. And of course, square root of 4 divided by 2, that's just the 1. Okay. And then the cosine, since they are what we called co-functions of each other, you take this whole list and reverse it. So 1 square root of 3 over 2, square root of 2 over 2, 1/2, and 0, right? So we reverse that list. Again, just showing you a fast, easy way of filling out this very important table of exact values. And tangent, remember, was what? Sine divided by cosine. So I'm just going to divide these. 0 divided by 1 is 0. The denominators cross out, so 1 divided by the square root of 3, which by the way is square root of 3 over 3, rationalized. When you divide a number by itself, you always get a 1. Again, dividing these, the denominator goes away, so you're just left with the square root of 3. And what's 1 divided by 0? If you said undefined, that would be very much correct. You are not allowed to divide by 0. So tangent of pi over 2 does not exist. There's no value for that. Okay. All right. So, of course, if you want secant, cosecant, and cotangent values, what do? Simply take the reciprocal of these numbers. So, this being said, find the exact value of, here it is, let's say, cotangent of 315 degrees. So cotangent of 315 degrees, what did we have to do in the last section? We had to think about the reference angle, right? So first of all, take this 315 degree angle, bring it back in first quadrant, yes, so I could use these numbers right here. So 315, sure enough, you can draw yourself a picture if you want to figure that part out. But 315 degrees fits in the fourth quadrant, yes. And the reference angle, in other words, how much more is it left to the x-axis? That's 45 degrees. Now, also think about the sine. Cotangent, or you can think of this if you want. It's cosine of 315, but it's too much, I'm going to tell you right now. Sine of 315, but again, I don't want to really bring them all because then now makes it think of two values, but okay, let's just do this now. So cosine of 315, cosine fourth quadrant's positive, so it's the same thing as cosine of 45, right? Sine in fourth quadrant is a negative, so that's negative sine of 45. So again, I'm bringing back what we've already learned in 5.2, so we went through all of this. So what's cosine of 45? That's square root of 2 over 2 over negative square root of 2 over 2, which by the way is equal to negative 1. Okay. Now, what would have been faster? Just thinking about it already. I could have thought about this in terms of tangents. That's 1 over tangent of 315 degrees. And again, fourth quadrant tangent's a negative. Okay, well, it ends up in the same spot. Equals to a negative, tangent of 45, of course, is 1, right? We have it in this list right here. Okay, there you go. Okay. So, however you think of it, you have to bring it back to your reference angle, and then bring it back to your reference angle, first quadrant, and you also need to think about very much about the sign. Okay, so how would I find cosecant of negative 150 degrees? Well, first things first, I'm not sure much about cosecant, except for it's the reciprocal of whatever sine is, right? So now that I brought it back in terms of sine, I've already learned in 5.2 how to figure this part out, okay? So cosecant, simply the reciprocal of sine, right? We bring it back to one of our main 3 trigonometric function values, right? And then we're good. Okay, so what is sine of negative 150? Again, I kind of have to think, and It's up to you. If you want to draw yourself a quick picture, nobody will get mad, but that's negative 150 degrees, right? We have to go in a clockwise direction. Okay, so there's negative 150 degrees. So that puts us in what? Third quadrant with a reference angle of 30 more to get back to the x-axis, right? So that's negative, again, sine in third quadrant's a negative value. Same number though as whatever sine of 30 would be. And sure enough, sine of 30 is 1/2, right? The reciprocal of that is 2. And of course, with the negative because of the quadrant we're in, okay? So that's how we think our way back to this table and to the exact values, okay? Let's do some more. What would be secant of 480 degrees? Okay. Well, secant of 480 degrees, first of all, is whatever the reciprocal of cosine of 480 degrees is. And now back in 5.2. 480 degrees, that's past the first time around the circle. So I'm going to use coterminal angles and bring it back down. So minus 360 degrees, right, gets us back to 120, the first time around the circle. So where is 120? 120, right, positive 120, fits in the second quadrant, right? Reference angle to go back to this x-axis is 60 degrees more, right? So first of all, in the second quadrant, cosine's a negative, yes. What's the value of cosine of 60? Cosine of 60 is 1/2. Okay, so that's a -2 as well. Okay. All right, what is cotangent of 5 pi over 6? Okay, so it's up to you if you want to leave it in a radians. If you're super good with radians, not a big deal. Again, the more practice you have, the faster you'll get to it. First of all, cotangent's the reciprocal of tangent. And now you have to think back of your table of values, right, that I have on the other page. Where's 5 pi over 6? 5 pi over 6, by the way, is in second quadrant as well. It's a leftover of pi over 6 to the x-axis, right, for a full-on 6 pi over 6, which is pi, okay? So in other words, the reference angle is 30 degrees. Okay. Tangent in second quadrant is a negative, yes. Tangent of 30 degrees is square root of 3 over 3, or 1 over square root of 3. So when I take the reciprocal of that, I can make it, oops, don't lose that minus. I mean, I didn't lose it, it's just I covered it. So you don't need to go back all the way to sines and cosines, but again, tangent of 30 degrees, look back at the table of values we just made, that's square root of 3 over 3. Take the reciprocal of that, and of course 3 divided by the square root of 3, that's just the square root of 3. So that's how fast it can go. One more time, I just want to review with you the signs. We did talk about it in 5.2, the mnemonic about all students take calculus. What does that mean? Means they're all positive in the first quadrant. In other words, what? Sine, cosine, tangent, and of course all three reciprocals of them. Only sine is positive in the second quadrant. Tangent and cotangent, tangent and cosine are negative. The only thing that's positive in third quadrant is tangent, yes. Sine and cosine are negative. And fourth quadrant, cosine is positive and sine and tangent are negative, right? And of course, their reciprocals go with that. So the reciprocal of a positive sign is positive, yes. The reciprocal of a negative is a negative value. Okay. So let's do some more. Just want to remind you of that, just in case you had forgotten where I'm taking all those pluses and minuses. So let's find tangent of 8 pi over 3. All right. Ooh, 8 pi over 3. Where would that be? Definitely that's more than 2 pi, right? Because 8 is 2 2/3, by the way. So you can think about radians really the same way you think about fractions, right? So without the pi, 8 over 3 is 2 2/3. So you've already gone past 1 full 2 pi, right? And it's the same thing as 2/3. Or 2 pi over 3, right? So again, coterminal angles, right? I'm bringing it back down. If you're not so good at fractions, no big deal. Turn it into a degree, right? Maybe that's better for you. So what is this as degrees? 8 pi over 3. Put it in degrees. The pi goes away. 3, that's 60. And guess what? This was the 480-degree angle that we were actually dealing with up above. Okay, so 480 degrees, again, I'm minusing 360, and I get back to 120. That's what 2 pi over 3 is. So it's a tangent, so I don't need reciprocals. Tangent in second quadrant's a negative. The reference angle of 2 pi over 3 is just 1 pi over 3, or in other words 60 degrees itself. Okay, so from 120, there's, again, we just went through that up above right here. Right, I drew 120 and the reference angle is 60. And what is tangent of 60? That's square root of 3. Okay, that's the exact value. All right, let's see one more. What about secant of negative, let's pick a negative angle, 3 pi over 4. Okay, so secant, first of all, I'm going to get that value out of a cosine. It's the reciprocal of cosine. Good. Where is negative 3 pi over 4? So I have to go in a negative direction. 3 pi over 4 is 3/4 of the way to pi. And the reference angle for 3 pi over 4 is just 1 pi over 4, right? That's the reference angle. So let's see about that. So cosine of this angle of negative 3 pi over 4, this is an angle in third quadrant, so that's a negative value, yes? And cosine, the reference angle of it, as I said, pi over 4. So it's negative, I put the minus up front. Cosine of pi over 4 is square root of 2 over 2. So that's the reciprocal. Right, I'll write it out. 2 over the square root of 2. And 2 over the square root of 2 is just the square root of 2. And again, the minus because if it's in third quadrant. Okay, last one. I have a little bit more space down here before we'll do another problem. What is cosecant of negative 210 degrees? Okay, where is negative 210 degrees? First of all, cosecant's the reciprocal of sine. So again, we're back in 5.2. What is sine of negative 210 degrees? What would that be? That's negative 180. And there's negative 210 degrees. Okay, it fits nicely for me in the second quadrant. Well, in the second quadrant, sine's a positive, and the reference angle, again, you're going back down to the x-axis, and that's just 30 degrees. Okay, so the reciprocal of 1/2, again, it's just 2. Okay, that's how we find these answers exactly. And again, they all go back to that nice table of value that I showed you how you can easily get. Okay, so let's see other applications. Here it is. If we know the sine value of some angle, then we want to find all the other trig values. of this angle theta. So in other words, knowing the sine value of some angle is 3/4. Can you find me cosine of it, tangent of it, secant of it, cosecant of it, cotangent of it? Okay, now this is not enough information. Why? Because and it matters very much the quadrant in which an angle ends. If sine value of this angle is 3/4, we still don't know where that angle could be. It could be a first quadrant angle. It could be a second quadrant angle. Remember, sine is positive in quadrants 1 and 2. That's very much important to know the quadrant for the other trig function values, right? Will they be positive or will they be negative? And this is why every single time we have to tell you also some other information about the theta or the angle that would disclose what quadrant it would be in. Maybe I'm just saying straight up it's in quadrant 2, or maybe I'm giving you another clue. Let's see next time. Okay, so how do I find the other trig function values? Well, the most important thing is, well, of course, if I know sine, I immediately know it's reciprocal. But how do I find the others? Remember, we had these other formulas right here. Yes? This is what's going to connect them. So if I know sine, I can immediately find its reciprocal. But I can't find the rest of them, or I can't find tangent because I need the cosine value. So I need one good leap of how to go from sine to cosine. And it's the Pythagorean identity that we've learned in the last section, that no matter what, because sine and cosine are values, right? Remember, let me just remind you of it, just in case maybe I haven't talked about it. But what happens, this is the unit circle, yes? This is the unit circle, and what do we know? If we pick some kind of angle theta, I don't care where and what quadrant it is, right? It could be in quadrant 2, it could be a negative angle in quadrant whatever, it doesn't matter. What happens with this angle theta? Wherever it terminates, I have to use its x and y coordinates, yes? And what do we know? We know that, again, being the unit circle, what is the equation of the unit circle? The equation of the unit circle is that x squared plus y squared is equal to 1. That's the equation of the unit circle, right? It has the center and the origin. The radius is equal to 1. These are equations of circles. So what else, what did we talk about? We talked about the fact that the sine value of theta is always the y coordinate. The cosine value of theta is always the x coordinate, yes? So, because you are choosing a point on the unit circle, and any point on the unit circle has to satisfy the equation of the circle, okay, then it has to satisfy that equation. So in other words, I'm going to reverse it. Instead of saying cosine squared plus sine squared, we're just going to write this, that sine squared theta plus cosine squared theta is equal to 1. What does that mean one more time? It simply means that if you take the sine value of the angle theta, you figured out what it is, and you square that value, and you take the cosine value, which is the x, right? This is the y, and you square that, you're going to always get the number 1. But we don't want to write so much because of the parentheses, so instead of putting sine of theta, again, be careful, it's if I write it like this, what would you think is happening? You would think of squaring the angle, right? But not the sine value. So to make sure that we're squaring the sine value, well, you put the whole thing in parentheses, or the shortcut for that is that we put the square to sine. Yes, okay. So by the way, this is called the Pythagorean identity. And why is it called the Pythagorean identity? Where does the equation of a circle even come from? Here. I'll make it more obvious and pick something in first quadrant. Yes. This is a 1. This is, I think we've talked about it, but oh well, I'm talking about it again. So that's the y coordinate, that's the x coordinate, right? So Pythagoras theorem simply says that x squared plus y squared is equal to 1. So this is why this is called the Pythagorean identity. And I might as well, since we're here, take you through the last Pythagorean identity. We'll go through that problem again. So our Pythagorean identities, again, coming from Pythagoras theorem, right? Leg squared plus leg squared is equal to the hypotenuse squared. So as I said, most important one is that the sine value squared and the cosine value squared of the same angle always add up to 1. Yes. What we can do in this equation right here is we can divide all sides. I'm going to divide the whole thing by sine squared theta. So I'm going to divide both sides by sine squared theta, and then what do I get? Well, sine squared divided by sine squared is equal to 1. Cosine, remember, divided by sine, that's the same thing as cotangent. And 1 divided by sine is cosecant squared. So there's one more formula. And if I take that Pythagorean identity, the main one, and do the same thing but divide now the whole equation by cosine squared, I'm getting this new formula here that says that tangent squared theta plus 1 is equal to secant squared theta. So these are huge. These formulas you're going to be using very, very much when you get to calculus, and very, very much when you get to pre-calculus. Whoops, you're in pre-calculus. There you go. So we're going to be using them quite a bit. Okay. There you go. Better. Sun came through. Okay. So these Pythagorean identities will definitely make it easier alongside with, let me just write them all, reciprocal identities. Which ones were my reciprocal identities? The reciprocal identities were what? The fact that tangent is sine over cosine. And I know I'm getting lazy, and I just say sine over cosine, cosine over sine, but have you ever seen me skip a theta? No, and I should not see that from you either. So you write cosine over sine without an angle in between. It's the same thing as you guys writing, here, I'll pick this, a square root over a cube root. Of who? Who am I taking the square root of? So the same thing if you leave a sign. It's a function. It's an operator. Who am I taking the sign value of, right? So you have to write something in sign. Same as you have to write something inside a square root. You can't leave it empty, right? It means nothing. So you have to put the angle. We don't say it every time. We're getting lazy, but never ever get lazy when you write it down. Okay. So these are the reciprocal identities. And finally, we have the, oh, Jesus. Ratio. I don't know. And here are finally the reciprocal identities. And the reciprocal identities were the fact that what? Secant is the reciprocal of cosine. Cosecant is the reciprocal of sine. And cotangent is the reciprocal of tangent. So sometimes I start off tangents and go over other things. Okay, well, there you go. So all of this, these are the connections between all our trigonometric functions. Okay, all 6 of them. So we can use these formulas for a whole lot of reasons. The first one is we're going to go over, I'm going to write that problem one more time. Knowing one of these values, it doesn't matter which one, you can find the other 5. So we're going to take a break right now, and then we're going to do those problems in the next video.